everybody. I appreciate you attending. It's always an honor to talk to meetup groups like this. I am Scott Moore from Nashville, Tennessee, and I wish I could have been there, but the schedules would not allow it. My background is performance testing, not functional testing. I'm typically using tools like Performance Center and LoadRunner, more commercial tools. I have used some open source tools in the past as well. But this is not going to be about using a particular tool to performance test HTTP2. It's about considering, well, it's basically started off with some research that I was doing about HTTP2 and how we should expect to see some big performance improvements as we migrate applications from one to another. And I'm assuming that I'm going to have to speak to various backgrounds that have various, technical backgrounds as well. So some of you may have development experience, some may not. I'm assuming that if you are testing HTTP applications, you understand fundamentally the protocol, what it's doing. You understand HTML, CSS, and some of these references that I'm going to make. So if that's not correct, just ping me after the session. But my viewpoint today is going to be about the protocol itself and addressing performance testing, how you can improve performance of an application just by moving over to HTTP2. And while it may not be true in all cases, in a lot of cases, there's going to be some big benefits. So start off by saying that this started out as just a research project for me to see. I don't like to just talk about things that I research on the web. I actually like to do it myself and test it myself. So I'm going to get into an actual demo that I am going to show you how I confirm some of the things for H2 are actually true. But in order to get there, I need to talk about where we came from, where we are now, basically what HTTP2 is, how some of the best practices are going to change with optimizing good performing websites, how things in the past may not be true for the future as to how we approach development of these applications. Then I'm going to show you the demo. So we're going to jump right into this. First of all, note that HTTP 1 has been around for about 20 years, a little bit more. It was initially intended to be a very thin protocol where we had simple requests and responses. It was meant for mostly plain text, maybe a couple of pictures, with simple requests and responses, get and post, get and puts. It does support compression and encryption, and over time, after 1.0, began to support multiple TCP/IP connections within a browser, as well as instead of 1.0 was just send one request, get a response, then send another request as a single request. We added pipelining in 1.1 so that we could begin sending multiple requests off and without waiting on the first request to have a response back. So with 1.1, we began to use the browser for things it was probably never intended to be used for initially, and because of that, and because the protocol hasn't really changed, there's been a lot of workarounds and things that we've had to do from a development standpoint to just kind of make things work, make things better, and make things more responsive. And if you remember the browser wars, the late 90s, early 2000s, with Internet Explorer, and then eventually we got Firefox and then Chrome in the mix, we began to see more and more connections per browser. That's going to be real important as we move forward in this conversation and we talk about HTTP2, because I think that's going to be the biggest change that we see. So knowing how to test this and test it even functionally, but to test this and understand it performance-wise, we've got to understand the major shift that's being made in this protocol. So there are the ability to do multiple TCP/IP connections per browser, but that was not necessarily ever a great thing to do, and I'll explain why next. Google sat down as a company and said, is there a way that we can actually improve HTTP fundamentally? Can we make it better? Can we make it faster? And can we default that to make it more secure as well? And what they ended up with was a protocol called SPDY, S-P-D-Y, and it was the beginnings of what eventually became HTTP2, and I'm going to call HTTP2 H2 because it's much easier to say. But SPDY was replaced with H2 as it became ratified officially. There were a few changes that were made between the two, but they look very, very similar. So it was designed to lower the latency across the World Wide Web. We'll talk about why that's important in the next slide. But the biggest problem we've had to solve performance-wise is head-of-line blocking. Every developer has to deal with that, in that I think of that as moving something back and forth over a chasm. So you can think of it like maybe moving across a bridge, across a river. I've got small things that are whole units of things that I could move across and use immediately, but there are much bigger things that may not fit in my wheelbarrow that I'm moving across. Hope you get this analogy, but I may take pieces of those and reassemble them when I get over to the other side and use them once they're reassembled. In HTTP 1.1, we were trying to get around that by using these multiple connections, domain sharding, by pulling resources from different domains to try to remove that problem where some resources that were small or text-based, very fast to get, we could get those and begin rendering those and using those as fast as we got them, and then worry about some of those large images, flash, and things of that nature afterwards, after we're starting to read that text. So we're also trying to limit the amount of stuff that's going across the pipe, so we want to compress it if we can, and we want to shave off redirects if we can. We want to look at cache more, but we also want some level of backwards compatibility. So you'll still see the idea of HTTP headers with your same status codes that mean the same thing. You're still going to have gets and posts, but there's going to be additional headers and modified headers that will not be the same. So that will be a change, but it is completely backwards compatible. As far as where we're at in the market, I started writing about H2 back in 2015, I think somewhere around February of 2015, and then followed up this year and then started speaking about it. But even now, the last I checked, I started working on this presentation back in May. As of August, we're still less than 10% of all web traffic. The web servers, this is an unusual case where the browsers actually are more ready for this change than the server side. So you can see the major web server players out there, Apache, Nginx, IIS, they're all ready with it. They have some level of support, some more than others, but it's not adopting as fast as I had hoped. I've got a website URL down there that you can check, and I believe they update that every month. But you can keep up with the numbers here. I would have thought this would have grown much faster. At least in stages we would get H2. But I think once developers started seeing some of the changes they had to make to the build process, some of the things they had to change concerning inlining, and starting to let H2 do some of the work they've been doing, I think they might have seen that as a much bigger transition than we originally thought. So we'll talk through some of these issues next, and talk about fundamentally why Google wanted to do this, why they wanted to reduce the latency versus why don't we just keep getting bigger and bigger pipes. So some of you may remember, in the good old days when we had 56K modems and then ISDNs, and then, wow, we get cable modems and we've got 5 meg connections, and now we've got Google Fiber going out to gigabit connections to the home and even higher than that, with other fiber connections competing with that. That's great that we've gotten a bigger pipe that doesn't cost as much. But if you look at this graph, you'll see that going from a page load time of 1.5 seconds at a 4 meg pipe, even moving that across to 10 meg or even a gig pipe, probably is not going to do as much as reducing the latency from, say, the 160, 140 milliseconds to down to maybe 100 or 90. You're gonna do more in terms of cost savings in rendering time by reducing the latency. So that's the most important thing that we want to try to do, and that was the goal of H2. So the biggest differences, and I think the biggest things we're going to see, the biggest bang for the buck on, are these 5 things that I've listed here. First of all, we moved from a text-based protocol where we can understand that as humans better to a binary protocol. So there's pluses and minuses, obviously, when you move to a binary protocol, in that text-based protocols humans can understand a lot easier and process, but it's overhead for the computer and vice versa. Binary stream becomes easier for CPUs to process with less overhead, but it's harder for humans to figure that out. So keep that in mind. Just from a binary standpoint, you're going to get some savings there. Then we're going to talk in detail about the other 4, but I'm just going to mention that it's about multiplexing and interleaving frames. That's one of the biggest change that you're going to see. A single, fast, secure connection. You're going to get automatic compression, and there's a special part of the spec for H2 called HPAC that compresses the header information. We'll talk about why that's important. And then server-side push and prioritizing of resources. Those are the 2 latest things that the web server vendors are kind of dealing with right now, as to how they're going to implement that, because they may be individual. The server-side push is from a web server perspective. The prioritization of resources is from the browser vendor perspective. And again, we'll talk about these next. So let's talk about these interleaved, multiplexed connections. So when you have your typical browser is making a TCP/IP connection to a web server, and then it makes up to 6. Remember, we're talking about the browser wars. Originally were 2 connections per server, and eventually 4, and then now we've got 6. I think you could probably get up to 8 maybe in Chrome, and those can even be modified in testing tools as well. You can modify the number of connections, but each one of those connections are expensive. The difference is HTTP2 is one single connection with multiple, I guess conversations is the word that I like to use, because you can see by the numbers and the colors here, there's at least 3 to 4 different conversations happening across this connection that you see. So we have the header information coming across, we have smaller data or text-based data, and probably larger data with larger images and things of that nature, all happening at the same time, kind of intertwined there. You can think it like a 3-chord strand that's braided, that's made up of kind of different sizes moving along. I'm not sure that's the best analogy. Does that always work well with every web application? Not always. I'm actually seeing some presentations now. In fact, one that I saw just recently last week, that's called HTTP2, What Everyone's Not Telling You, in that there are some cases where HTTP2 can be slower, and we'll talk about that as well. But you can see here that you've got this idea of this connection, and the one thing I hope that you get from this presentation is that each connection is expensive, but in H2 the difference is the individual requests are no longer expensive. That's going to be important. It's also secure by default. There's nothing in the spec that says it has to be secure, but all the major vendors are going to require that it be secure. And TLS 1.2 is what it is currently using. There are specific ciphers that will not work. It forbids renegotiation, and it is supposedly safer because of this. There is a version called H2C that is clear text. While it won't be supported by the major browser vendors, there may be, I haven't seen it in production, but it could be implemented, but maybe it's not for a browser-based application. Maybe it still uses the protocol, but it's not a typical browser app. But yes, it is still hackable. Imperva was the vendor who came to Black Hat this year and listed the 4 major vulnerabilities with H2 that they've outlined in a white paper that you can get online. And those things are being reviewed and addressed right now. But so obviously the game still continues between the cat and mouse on the security, but at least we start off with a secure protocol from the get-go with vendor agreement. So how do we begin to start optimizing this? We talked about the fact that when you have multiple connections, one of the things we try to do is do domain sharding, which is multiple domains and splitting up your resources to be pulled down between them. While that was great for HTTP1, H2, this could work against you. It's also frequently abused and can cause congestion, so it's probably not a good idea for H2 because we have that one connection. And obviously, less DNS lookups are good as well. Let's talk about TCP slow start, because I think that's the biggest thing I wanted to get to in talking about these 6 different connections. In TCP/IP, there's this idea that, okay, TCP begins to talk to web servers and routers, and it starts off at a certain speed, and then it will begin to increase how much packets, how much traffic is going across the wire, until it reaches a saturation point where packets are being dropped. And I kind of liken this to the old I Love Lucy episode where they're at the candy belt, you know, the rotating belt, and they're trying to fit candy everywhere they can because it keeps dropping off the belt. It's kind of what's happening at the router side, saying, whoa, you know, stop, we're losing stuff, retransmit the stuff that we're losing, and slow down until we get to a point where we've minimized or gotten rid of all those dropped packets. Once it finds that right speed, then it will continue on. Now you multiply, that takes a little, but you multiply that times the 6 connections that are being used by a browser, then you kind of understand some of the issues that, and why we're trying to work around minimizing the number of requests that we have. We want to put as much through per each request and response as we can to minimize the back and forth because of that. So you want to have more concatenation with HTTP1, meaning you want to take all those small client-side JavaScript text files and you want to merge those together. You want to merge multiple CSS text files together when you're shipping those down so that you have more concatenated. But now with H2, since that doesn't matter, it's actually faster to have these smaller requests and responses. And that's really where it begins to shine, you'll actually see. Spriting was another workaround where we take a large image and then we take smaller pieces of that image once we get it down and just refer to local cache to show what we want to show on that page. And it's very fast from a user experience. Spriting probably won't totally go away, but it's probably better not to use it or use it very wisely because of those individual requests are cheap now. So I'm going to show you in my demo where that really works to our advantage to use H2 when you have a very graphically oriented website with many small files. I'm going to prove that to you. When we talk about concatenating files, inlining is one of those things where you're taking CSS files and you're putting the graphic representation up in the CSS file so it comes down at the same time. What that's going to do, if you continue to do that, is that's going to work around some of the built-in things that H2 would do for you, and it would do it smart. It would give the ability to change the priority or change how that works per application. So you'll be working around the ability to decline, or for a browser to decline in inline images. So when we talk about prioritization of resources and server push, that's where we get into those features of H2. Again, concatenated assets. Usually you have these small JavaScript files and there's an extra step in the build right before you produce that release where all of those get smushed together as one larger file so you don't have 15 to 25 different small text files being moved across. That idea kind of goes away, and it makes your build process simpler as well. That was obviously done to deliver better compression, to reduce the number of round trips, but again, it causes a lot of problems with H2 because now it starts messing with your caching, and it starts delaying the processing of certain things that H2 would want to process maybe sooner. So you want to feel free to ship granular resources and then look again at your caching policies, which I'm going to talk about in just a minute. I want to talk about compression first. Just by moving over to H2 and changing a setting, like if you were using Nginx, it's a one-line code change, and assuming that all your dependencies are right with security, you're going to get up to, we've seen up to 75% compression on the headers. And this compression that's being used is the Huffman code compression, so it's the same thing as gzip, really. But think about all the traffic going back and forth today with HTTP1, where the header information really doesn't change, but that information that comes along with all that data is being repeated over and over and over again. So why not use compression on that and give me only the things that I need to see on the other side, and make sure that it's compressed as it's sent over the wire, which means less stuff goes over the pipe. It's compressed, it's much smaller, so you're better utilizing your bandwidth as well. So just that one change can be a great improvement to your site, even without any of the other optimizations that we've mentioned. So really, second major thing that I hope you get out of this presentation is that if you can move over to H2 and just get the compression out of it, you may get a hit out of the park with that. If nothing else, could be a very incremental, good incremental change in performance. And if you don't do it, you're really leaving money on the table because of all the overhead, and there's costs involved in not compressing, basically. So let's talk about server-side push. I will get to caching, I promise. We talk about server-side push. This is the server looking at what's being requested and saying, okay, Mr. Browser, you've requested this HTML page. I know what's in this HTML page because I know what the tags are referencing. And I know that you're going to want these other resources, these GIF images, these style sheets. So why don't, if I can, in the initial request for that HTML file, why don't I send you down some of this other stuff as well, put that into your cache, and then by the time your browser is asking for it, it won't have to come back to me to get it as a separate call. It'll just go straight to your local cache and grab that. This information this is all done through headers. It's not set in stone, meaning that the browser can say, no, I don't like what you're trying to send me. I want to request it in a certain order. So each web vendor can make a decision on how they implement server push. And it's not something that you want to do all the time, but for the specific pages, if you look through your happy path that people are taking, you would probably want to optimize server-side push for that happy path. And that will give you a really good gains on key, like say web forms, where performance is going to be critical. So look at the traffic patterns and make those decisions. So that is something that you'll need to work with the web server vendor on. The CDNs that are out there right now are pretty much ahead of most of where everybody else is at, and they're the ones that are talking about server-side push the most. So those are the places that I would look for: Akamai, Cloudflare, and places like that. On the other side, you've got the client side, which is request priorities. Now, you don't see a whole lot of talk about this yet. I'm starting to see more and more about it, but it's basically the browser. You can almost think of it like a hierarchical tree or XML tree with subtrees and algorithms that are going to be smart algorithms to know what they want and how to prioritize different resources in a certain way that will make that page render faster. So it may put a higher priority or a higher weighting, W-E-I-G-H-T, a higher weight on text-based files like HTML, CSS, client-side JavaScript, and then put a different weighting on GIF images or something else. Again, this is something that the browser vendor is going to decide how to do. It's not something you're going to be able to go into tools and options and make a setting change and do. So I'm interested to see how this is going to lay out between a browser that has made a decision that it wants to pull things down and render it a certain way versus a server that wants to do server push in a certain way, and they begin to fight with each other. That's going to be interesting how they figure that out. The best place to find out more information about some of this stuff that is, I guess, more newer pieces of the spec that are being implemented is to check with Google, because the Google engineers are really on top of this. They're talking right now about a manifest.js file, which is a text-based file on the server that would basically set those priorities and allow you to start setting that server push and priorities on that side. So I would look on YouTube under the official Google webcast that they have, and they will walk you through the latest implementations of this and the latest information of how they're implementing it in Chrome and on their servers. So I said I would talk about cache. Before, when we dealt with caching and how we cache, how long we cached for, was always based around the idea of we've got to look in terms of how much stuff am I going to pull across the pipe. If I don't cache it long enough, I'm going to be pulling more stuff down. Now that requests aren't expensive anymore, you sort of have to just look at your cache plan again and say, okay, how expensive is it going to be if I invalidate sooner, or do I still need these long times, or are there specific pieces of my code or specific areas of my site which are going to be more stable or change more, and those are where I'm going to want to alter those cache values. So everything that you do is going to be based on that. I've got a single fast connection, and I can do all these requests and responses without the big cost. So to recap what I said, less domain sharding, no more sprites. It's probably, in my opinion, probably the best way to go, but some people would probably argue not always. You're getting security as a default. You're getting free compression out of this. And you also get these algorithms for server-side push and request priorities. So to me, those are really good reasons from a performance engineering standpoint to expect that your web application can vastly improve if you follow through with changing it over and some of these best practices. Now, obviously, these aren't all of these. I think what you're going to see is the Steve Souders approach to responsive websites on the front end probably going to be revisited, and it's going to be changed. And Steve may have already looked at these and changed these to evaluate it under H2. So some of these are just, duh things and could be for both, but reducing the number of DNS lookups, reusing a single connection instead of using 6, obviously using content delivery networks. If you're not using CDN servers, you should be, and you should look for CDN servers who are already supporting H2, minimizing redirects, unnecessary requests, compressing wherever you can, optimizing your cache, and just eliminating any unnecessary resources, which is another duh. But I do want to mention that people may be looking at this and saying, okay, well, this is a lot of changes, and you've told me that I'm going to have to make changes for inlining and things that we typically do right now for our build. So we can't just go all in on this without, proper testing for all this. So you can take a multi-stage approach, and you can do at least 2 of those stages without making any code changes. So just by moving over your CDN assets to H2, you get the compression at least on the headers for those files. So that's a start. You may choose to implement an H2 proxy in front of your web servers so that you get the compression at least on the front end. And then when you're ready, you may decide without still making any code changes, just fully move over to H2, but with your existing code. Now, that doesn't mean that just because you move over to H2 that a really poor performing website is just going to perform 10 times better. It's not. But just with what I've mentioned here with the compression values, you'll probably see something. And as you're going to see in this demo next, I think there are cases where if you've got a graphically intensive website, you should see drastic improvements on smaller types as well. The only disadvantage that I see right now is there's not enough of H2 to go around to see all of the issues that we might come across as we're testing and implementing these things. And we don't have a complete standard across all the web server vendors. So they're going to all have to get on the same page, especially now on server push and prioritization of resources. Trying to maintain 2 different sites where you have both versions and an optimized version, that's going to be pretty weird to try to do. It can be pretty complex depending on your app. But like I said, if you take that phased approach, that's probably the best way that you could do it. So now that I've talked around 35 minutes on that, a couple of things I'll also mention is products and tools. I don't know a whole lot about the open source tools that might support H2 because I've done some searching. I didn't find a lot. Most people that are at that level are doing basically curl. They're using some command line tools that are out there and doing testing that way. There are ways that you can determine if a web page is using H2 or not. There's an add-in to Chrome that you can add from the Play Store, and it just puts a little lightning bolt on the browser. And most popular pages you can find are google.com and twitter.com. And if you have that add-on in Chrome, the HTTP2 indicator, as soon as you go to that, it lights up. So there's other sites out there that you can find tools as they become available, but two I'll mention. The one here that you see, HTTP2 test, the verification of support. That URL is very helpful for the Keys TDM, but also if you will go to cloudflare.com, or you'll do a Google search on Cloudflare and HTTP2, you'll see some of the tools that they were using to optimize their servers for H2. Tools I am familiar with, LoadRunner 12.53 offers H2 support. I know that NeoLoad, the latest version, supports it as well, and Wireshark also supports it. And so even though the traffic is encrypted, there's a way that you can set up a key file in Wireshark, and there's websites out there that will walk you through it. It takes you 30 seconds, and you can start seeing the headers and the data. The interesting thing about LoadRunner, I do want to mention this, there's keyword here, dependencies. In LoadRunner, we have to go into a section called Advanced Port Mapping Settings, and I've never had to even go in here before in my 20-year career and change a lot of this for an application, but with H2 you have to. But the reason I'm showing you this screen is because you'll see the different versions of TLS that are supported here. And this actually came back to bite me as I was testing against this, because you see TLS 1.2, TLS NPN, and TLS ALPN. ALPN is required for H2. NPN would have been used for testing the Speedy protocol, which had been available in previous versions of LoadRunner. So as I began to use the products to this, I noticed a couple of things. I noticed that I couldn't finish the script. I would play the script, and it would get to the last step, and it would completely hang. I couldn't figure that out. I also noticed once we got that fixed, the support, that the fix had to do with the header information. And then I realized from my research that the headers for H2 do change, and there's some additional stuff in there that probably at R&D they didn't think about having to utilize that information. But there are dependencies in LoadRunner for that. So the last thing that a LoadRunner script does is look at the header information and do some calculations based on some of those fields, and it couldn't do those calculations, so it couldn't finish. So we had to turn off replay statistics in LoadRunner in order for that to finish. Because we turned off replay statistics, there are other things that appear after a script runs in the replay summary that would not display on that screen because we had turned that off. So that also is disabled. So those things will be fixed in the next version. We also did find a bug with the Nginx web server specifically with LoadRunner that had to be addressed, and there is a patch for that. So I expect the next major release will have all of that stuff kind of ironed out. But again, remember the difference between NPN and ALPN, because we're going to get to the demo next, and that's going to become important. So here's what I did. I decided to set up 2 identical servers in the cloud using Ubuntu 14.04, putting the latest version of Nginx out there that supported H2, put a simple website out there that just had my logo broken up into 300 small PNGs with rows and columns, and I was going to, first of all, just look at it in the browser, in the Chrome browser, and then I was just going to run a simple test of LoadRunner, going up to 10 virtual users, running it for about 10 minutes, and then going down, because I just wanted to see the impact of 1 versus 2. And there's a lot of detail in setting this up, and a lot of detail in the actual test results, and I will run out of time if I try to get into that level of detail, but I have got links that you can go look at and get into as much detail of this as you would like and recreate this experiment, because it's not that difficult. So with this file, I had identical servers with identical specs, and the only difference is we went into Nginx and turned on H2 instead of H1 and went to those sites to the Google browser. This is what the web page looked like. So not much going on here, just simple HTML, and most of that's just static stuff. The only thing you see down at the bottom is I put some JavaScript there that would tell me what version of TLS I was using, and I also put this page load time. That's just a little piece of JavaScript, and in the links I'm going to share with you, I actually have the JavaScript code. You can paste it and put it in your own HTML file and recreate that. But it tells you from the JavaScript point of view with a specific formula, this is how long it thinks it's taking to render that page. When I actually did the load test, I took that code out, so that's not even part of the overhead, but it was part of the request that you're going to see next when I request it through Chrome. But that's what it is, 20 rows, 15 columns, 300 individual images, and I put that on each page. Whenever I actually looked through my log file when I was scripting against this site, you'll actually see there this HTTP 2.0 proves that I actually am pulling H2 traffic, but a lot of these other header values and named pairs will be very familiar to you. So some of them may look the same, some of them may look different. That's really it. And you can see there that content encoding gzip, so it is using the same compression as gzip. That's that Huffman encoding algorithm. Okay, so here's the actual experiment. What I did was went to the page with, I had never went to the page before. I cleared out cache, went to the web page for the first time, and then that's what you see on the left. The thing you see on the right is the exact same thing, except I just hit the refresh button. Okay, so we had the default, cache settings in the browser. We didn't change anything to that. So the main thing I want you to see is at the bottom of these requests. You have 304 requests. The page size came out to about 500K, which is what I was shooting for, about 500K. And actually, that's probably a smaller web page than you would see on some big graphically oriented sites. It's grown as our bandwidth has grown. But you can see there 500K transferred, and it took 7.5 seconds to fully render that page and to pull all those images down, because each one of those are requests, and you got 6 connections making all of those requests to pull them. You would think that would be really, really fast. When I hit the refresh button, as you can see on the right, I'm only pulling down 71K versus 500K. So that means most of those images are being seen from the local cache. I don't have to pull those down, but it still took 9.6 seconds because I'm still making those same connections. Those connections are still active and still looking to see whether they should pull them down or not. So do I need to pull this down? No, I'm going to look at cache. So it doesn't get any faster with this scenario, even though the DOM content loaded value is much less from a refresh perspective. So from a user standpoint, and you could manually do this and watch it yourself, each one of those requests, the first one and the refresh, what appears to be the same experience from a user perspective. So I thought that was very significant. So as we move that over, now notice the difference in the file size, 500K, 71K. So in HTTP1, we don't get any header compression. When we move over to H2, I don't know why it was a 5K difference in the size. I couldn't explain that, but we're the same number of requests. It's the same page. Notice the initial request was only 1.62 seconds. Remember, this is across the same type, at almost the same time, identical servers sitting in the same spot on the cloud. So there shouldn't have been any major difference from a networking impact perspective or a server spec perspective. So 1.62 seconds, but then I hit the refresh button and I'm only pulling 53.3K. Where's that 20K difference? That's the header compression working for you. So we reduced by that much. Now, that may not seem like much for this page, but if you multiply that out times all the web pages that you have in your app by the number of people that are requesting them, that can be significant on its own. So not as big of a difference between the two, and 1.62 and 1.02, but both of them really, really fast, and DOM content load is about the same. So I thought that was a very interesting conclusion that we can draw, especially when you have these small images, lots of requests. And here's what it looked like when I ran that test from a user response time. As I ramped up the time, the average response time did grow, and blue is H1. So we stayed somewhere between, the lowest I saw was 4.5 seconds, and the highest was 11.5 seconds. But right there, we're about the 7 to 8 second response time generally throughout this test. And you can see how much lower H2 is just in general with all factors being the same. And I would say that whereas it used to be the 8-second rule for web pages, we're probably concerned more about a 4-second rule now because we're expecting responsive web pages. We're expecting client-side AJAX and JavaScript libraries to make things faster from a rendering perspective on the user experience. And you put mobile apps in there and stir it up in the mix, you're expecting much lower page times now. This was the biggest difference that you're going to see. What I've been talking about throughout this whole presentation, which is the number of connections. So yellow being H2, I told you I ramped up to 10 virtual users. There's 6 connections per user, so maximum number of connections for H1 obviously is going to be 60. Held those connections open, it's only going to be 10 for H2. So server overhead being much different because of that, the number of connections that are open. And I kind of alluded to this. The presentation that talks about what other people are not telling you is they're basically saying that there are some instances that when we do this, when we reduce the number of connections and we're maximizing those single connections with TCP, we're then taking that headline blocking and moving it down in the stack, in the protocol stack from HTTP into TCP, which can cause other problems. So you're going to have to obviously look at this app for app. But in this case, those were the drastic differences. So I know there's probably a lot of questions about digging more into the weeds about this and why did you see this and what happened there. And just for time purposes, I just didn't have time to get into it. But there are 2 articles out there that I have on LinkedIn, and I'll make sure that Mike can get these URLs to you if you don't catch them on here. But the first one is just about H2, and what I explained is how we got to where we are today, and in much more detail. If you want to get into frame sizes and response sizes and all that detail, but where I initially found out was from a guy named Steve Gibson, very famous guy on the internet, and he was out on a blog, it was a webinar called Security Now, podcast, not a webinar, a podcast called Security Now with Leo, and he was talking about this new protocol H2, and he dives very, very deep into the protocol and the frame sizes and everything from the spec. And that's where I started from, and I've got a lot of links on that webpage. The second one is this demo that I showed you in much more detail, and the YouTube video is me explaining how I set it up, and I walk you through me getting on the Nginx web server, the configuration files that I changed, the HTML source, the JavaScript source code, and what the pages look like and how to get there from. These pages that I was looking at here are from Chrome. These are the developer tools, and this is the network tab that I'm on. And the only thing I had to do to change was you can select which columns you want to see, and I had to modify some of the columns that I wanted to see here. But you can see the protocol type is H2 versus protocol type in that column HTTP1. So that's how you would know. Now, one last thing here, and I'll be done. The other thing that bit me, you'll notice that I told you that I selected Ubuntu 14.04, and I told you there was a significance between NPN and ALPN. Well, 14.04 is a little bit older version. The current version of Ubuntu people are using are 16.04. And if I would have chosen that OS, I probably wouldn't have seen the problem that I've seen. I'm right in the middle of my demo, and I was doing this over about a week. And the weekend that I took a break was the weekend that Google updated the Chrome browser to version 51. And I had automatic updates on, so I didn't even notice that there had been this big change. So I noticed that on Friday, my script was working, and I'm looking at these Chrome network tools, and I see HTTP2 on Friday. I look Monday, it's back to 1.1. And I'm like, I didn't change anything. What happened? So I looked at the changes they made to Chrome 51, and it said completely removing all speedy support, and that includes NPN. I thought, I wonder why, because it's going to revert back to 1. If it can't process 2, even though you have 2 turned on the web server, it will default back to 1. So that means that the security connection, the TLS version, there's something going on with that because it can't negotiate that secure connection. So that was what was blowing up. And as it turns out, again, a dependency got me. The OpenSSL application supported Speedy, but it didn't support H2, the ALPN connection. It only supported NPN. So now that Google had removed that from the browser, no more NPN connectivity, so it reverted back to 1. So we went back and updated OpenSSL, and it began to support it again, and all of a sudden I'm starting to see H2 again. So it not only broke that for me, but in production systems that were using H2 and still using older versions of OpenSSL, they also got bit at the same time. So I'm glad that it only affected my testing lab and not a production website. So those are some of the things you've got to keep in mind when you're rolling over. There are going to be dependencies. You've got to make sure all those things are lined up to make sure that this thing works. So I hope that helps you with testing some of these things. And with that, I can take any questions, or Mike, I'm going to hand it back over to you. And if I didn't, make sure I address any questions that have come up.
Thanks, Scott. That was awesome. You actually covered all the questions that the meetup members have put together. Is there anything else you wanted to say before I said the closing comments?
No, other than you mentioned that I'm delivering this at CMG Impact. I'm also probably going to do this for Vivid as well. So if you know about the Vivid community, probably be doing this. If you missed some of it, or you know somebody else who might want to see this, you might want to tell them to look for that, and I'll be announcing it, I'm sure. If anybody wants to connect with me, I'm really easy to find at scottmoore.consulting, and I'm happy to talk or answer any questions even after this presentation.
Great. Well, thank you, Scott, for a wonderful presentation, and thank you, everyone, for attending today's webinar. Lastly, I would like to mention that QA Source offers a free weekly blog on blog.qasource.com. You will find topics on performance testing, automation testing, manual testing, mobile testing, and best practices for QA and managing your team. Thank you, and have a wonderful day.